Now we're going to talk the last topic. It's a review with a couple things added in. So what I want you to do is be able to read this table. This is really kind of the last skill, and then usually it'll be a multiple choice kind of skill. I've seen it, I think, one time as a free response question a while ago. But it is reading this output table. So we have this output table here. This is that LSRL, least squared regression line thing. So let's kind of walk through. Desiree is interested to see if students who consume more caffeine tend to study more as well. She randomly selects 20 students. So in this case, we know that our sample size is 20. And records the caffeine intake in milligrams and the number of hours spent studying. A scatter plot of the data showed that there's a linear relationship. That's important. We need to be able to say that it's a linear relationship from the scatter plot. So they told us that. If we didn't have that, we would really need to see the scatter plot. So here's the output. So again, let's go over the stuff that we know from before. The first thing I need you to do is anytime we see this number right here, R squared adjusted, we are never, ever, 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 ever going to use that as an answer. I can guarantee you 100% that that's not an answer. So please just cross it off so you don't accidentally use it. So now what we talked about before is we actually talked about a few of these numbers. And the numbers that we talked about were, we talked about this number right here. We talked about, what was it? This number right here. We talked about this number right here. And we talked about, which one is it? This number right here. We talked about this orange one. So those are the four that we talked about before. So let's go over all of them, make sure we got a handle on them. Just as a reminder, this number right here is your slope. I'm sorry, this number here is your y-intercept. My mistake. This number here is your y-intercept. What that is saying is the following. As an interpretation, what we would say is the following. So for my y-intercept, when a student takes 0 milligrams of caffeine, the predicted, that's the important part to put in there, the predicted hours of study would be 2.544 hours, 2.544 hours. Okay, so again, the big part about it is make sure you put the predicted, don't say the hours of study would be 2.544, because then you're guaranteeing it. So we use that word predicted. So that's our y-intercept. Okay. Next thing we talk about is we talk about this number here. This number is the slope. This guy right here is the slope. He's the slope of the line. And our interpretation of the slope says for each increase of 1 milligram of caffeine, the predicted hours of study would increase 0.164 hours. So for every milligram of caffeine, we would predict an increase of about 0.164 hours of study. So that was our slope. The next thing that we talked about before was this one. This guy is called the standard deviation. So this is our standard deviation of the residual. So what that's basically saying is that when we make these predictions on average, how far off are they? So the interpretation of the standard deviation of the residual would be, on average, the predicted hours to study will vary 1.532 hours from what is observed. So it's basically like the error of the model, if you will. Okay. And then the last one, this guy right here, the R squared, He's called our coefficient of determination. It's a name we have for him, the coefficient of determination. So the coefficient of determination, the R squared, it's that weird sentence I wanted you to memorize. It's one of the few, 60.032% of the variation in hours of study, my response variable, can be explained by the LSRL of hours of study, my response variable, on milligrams of caffeine, my explanatory variable. It's basically saying that if I look at the scatter plot, in essence, how many of the dots on the scatter plot could be represented well by this model. So those were the ones we talked about last time. There is one more I can get from this. I can actually get the thing called the correlation coefficient. And that's going to be my R. And the way you get the R is equal to the square root of R squared. So we're going to do R equals the square root of 0.60032. Remember to turn it into a decimal. And when I do that, I'm going to get two possible answers. I'm going to get positive or negative 0.7748. And the reason I'm going to tell you I know that it's the positive one and not the negative one is because my slope is positive. So that tells me that the correlation coefficient here is actually the positive 0.7748. And in our interpretation of that, this is a moderately strong positive. And because it says linear up here, I can say a linear relationship. So that's what we talked about before. Now what I want to talk to you about is the stuff that is new. There is some new stuff that we're going to deal with here, and I want to kind of walk you through what the new stuff is. The new stuff is some of those other numbers. Now, I will start off by telling you the following. I would say it is incredibly unlikely we're ever going to use this. I don't know if I've ever seen a question, but once you understand these, you'll understand what these are. But I'm going to tell you that realistically, those are numbers you don't need to know. We do need to know those other three numbers. So what are those other three numbers? Those other three numbers have meaning. This number here, if you actually look in this column, it says SE. Hopefully you remember that that SE stands for, and what this guy stands for, is called the standard error of that number right there. It is the standard error of my slope. What it's saying is that how much variability my slope has. That on average, like when I look at that, the slope will, if I were to keep looking at the slope's going to be off by about 0.057. That's the standard error of the slope. Since this is a statistic, this is the standard deviation of that statistic. Okay, that's the first one. This one right here under the T column is actually going to be your T statistic. And let me kind of walk you through what test you have here, because what we're doing is we're running a test on slope. And the null hypothesis on this test on slope is we're trying to determine if there's a slope. So the letter that they use for slope is B for beta. The null hypothesis is that beta is 0. 0 is a horizontal line. Horizontal line in the world of statistics means there's not a linear relationship. This is saying no linear relationship. Because what I'm saying is that if I had a horizontal line and I was using that to make predictions, what would happen is every one of these inputs would give me the same output. That's not a linear model, and it's not a valid linear model. The alternative hypothesis is it's a two-sided test that beta is not equal to 0. That means beta, that the slope is actually a non-zero number, basically saying that it's linear. Because if the slope of a line is not 0, it's got some sort of pitch to it. So there's a linear relationship. So what we have here is we have a test, a null hypothesis and an alternative. And with every test comes a p-value, and that's what that guy is. That guy's my p-value. And very small p-value, right? If I were to compare that p-value to an alpha of 0.05, it's less than any kind of realistic alpha. We would reject the null hypothesis. In other words, we would reject that there's no linear relationship. We would conclude that there is likely a linear relationship. So that is what those three numbers are. It's the standard error, it's the t-statistic, and it's the p-value. Now, let me show you where those numbers come. First of all, that number you're never going to have to calculate. You're just going to be given. Okay, but let me show you where they get that number from. The way they get that number is the following. Go on down here. So remember our t-statistic, when we dealt with it before, was x bar minus mu over sx over the square root of n. That was what we dealt with as our t-statistic for one sample. Now, I will tell you, this guy down here is my standard error. That's my standard error. So this guy down here, bring it back up. This 0.057 is this number down below. So realistically, 0.057 goes down below. Now up top, what it's going to be is instead of x bar, we are going to use b. B is how we represent slope. Instead of mu, we're going to represent beta. So it's b minus beta. This is my slope b right here. So it's 0.164 minus, well, the beta that I came up with up top was that the beta was 0. And if I put that into my calculator, 0.164 minus 0 divided by 0.057, I'm going to get 2.862. 2.862. So this number divided by that number gives you that number. And the way we figure out the p-value is you're going to be given it. I'll show you in a moment on how we do the confidence interval here, but this is basically a test for slope. It basically says, here's what I think the slope is based on, well, here's what my slope is based on my data. I then ran a test and I found out that the standard error of all of those points that I have on my scatter plot is 0.057. Again, you're never going to have to calculate it. You're just going to be given it. To figure out the statistic, slope divided by the standard error gives you your t-statistic, and then that t-statistic has a corresponding p-value. So that's our test. That's our test. Last thing I want to show you is I want to show you how you get your confidence interval. Your confidence interval is going to be this. B plus or minus t star times standard error b. So let me tell you, we got our b. 0.164. We got our standard error. We need our t star. And if you remember back to the beginning of when we did this for means, anytime we dealt with means, we dealt with the degree of freedom. And every time we dealt with the degree of freedom was n-1. This is the only time it's not a -1 situation. This is an n-2. And the reason it's a -2 is because we have an x value, we have a y value, we got these two variables, so we're going to do -2. So in this case, our degree of freedom is 20 minus 2, which is 18. So now to get that t star, go back to this table, 95%, drag our finger up till we get to 18, 2.101. 2.101. There's our t star. There is our formula. And when we actually went, if we went and expanded this out, we'd have to do it by hand. This is what you're going to get, 0.44, comma 0.284. And what that says is that this is, I'm 95% confident the real slope is somewhere in that area. And if you notice 0 is not in that interval, which that tells me I believe that there's a positive relationship between consuming caffeine and the number of hours you study. I know that's a lot, but I will tell you, realistically, this is a multiple choice question. And if you kind of had the connection, that's great. That's the multiple choice question. If it's still kind of a little confusing, just realize it's typically one multiple choice question. The rest of the class, we're just basically going to discuss multiple choice. So please feel free to ask questions. And our first attempt at the final exam is going to be next class. So please get ready for that 40 multiple choice questions in the 90-minute time frame. Thank you.